Okay. So, I'm obviously recycling an old test. This is the answer key to that test. We're going to review through this, and like I said, I'll change a few things on here, but this will be basically the test. Okay. Also, this isn't the same one, is it? Because I didn't. Oh, okay. Never mind. So, and if you see any differences between what I'm projecting and what is on your handout, let me know. So on yours, I've called this Physics Test Projectile Motion Study Guide. We didn't talk about relative motion, and that's not something that we have to talk about in this particular curriculum. But most of these multiple choice questions cover concepts that I need you to be aware of or make sure that you understand related to motion in two-dimension and projectile motion. And I also won't have these questions in the same order on the actual test, so don't bother memorizing. You can certainly memorize the questions if you want to. I'd rather you understand them, but they won't be in the same order, and the answers won't be in the same order either. There's also some information about how that particular class did on each of these questions, so you can kind of get an idea of which questions were more difficult for people and which ones weren't. Okay, so we're just going to go through these. We probably will need to use Friday as well to finish this. Obviously on Wednesday we're going to have our lab. So we'll get through as much of this as we can today, and then we'll use Friday to finish it up. Ignoring air resistance, the horizontal component of a projectile's acceleration. Okay, and this doesn't matter if I've got that kind of a launch, an angled launch, or a horizontal launch. It doesn't matter. What do I know about the acceleration in the horizontal direction of projectile motion, of two-dimensional motion?
Well, if you're ignoring air resistance, it's just going to continue to increase until something stops it.
Okay, not quite what I was wanting to hear. In the horizontal direction, what do I know about the velocity in the horizontal direction? It's constant, right? It's constant. So is there any acceleration in the horizontal direction? There is no acceleration in the horizontal direction, right? It's constant. Doesn't matter whether it's horizontally launched or angled launch, that motion in the x direction is constant. So you have to read these questions very, very carefully. There is no acceleration in the horizontal direction. Okay? Ignoring air resistance, the horizontal component of a projectile's velocity. Huh?
Is it the horizontal velocity? It's constant,
yeah,
right?
It remains constant. Okay? Most people got that right in the last time I gave this test. So for projectile motion, velocity in the x direction is constant. And actually I should kind of cover up some of this so that we can do it without you seeing the...
Well, we have the answer.
I know, but don't look at them. Okay? Soccer ball is kicked at a velocity of 12.4 meters per second at an angle of 37.8 degrees above the horizontal. So soccer ball is kicked like that at a velocity of 12.4 meters per second. What is the vertical component of its acceleration as it travels along its trajectory? What's the vertical component?
-1.8 meters second squared.
Okay, it's just the acceleration due to gravity, right? Right here at this point, the acceleration is downward at 9.8 meters per second squared. Right here, it's downward at 9.8 meters per second squared. It's downward, 9.8 meters per second squared. Wherever it's at along its flight path, the acceleration in the downward direction is the same. And as it goes up, its vertical velocity does this, right? Its vertical velocity slows down. As it goes up, that 9.8 meters per second squared in the downward direction causes that vertical velocity to get less and less and less and less until it gets to that point at the midpoint where its velocity in the vertical direction is 0. But remember, gravity hasn't changed. It's still there. And so everywhere along this path, it's 9.8 meters per second squared. And then as it goes back down again, the velocity in the vertical direction speeds up again, right? Okay? So this can be confusing. A lot of people miss this, even if they understand it. Okay? Even if conceptually they kind of understand it, a lot of people will see this angle of 37.8 degrees and think that I have to have the sign in there, okay? The velocity, the acceleration due to gravity is always straight down, period. Never not, right? A ball is thrown with a velocity of 20 meters per second at an angle of 60 degrees above the horizontal. Okay, so I kind of throw it up. What is the horizontal component of its velocity at the exact top of its trajectory? Okay, at the exact top of its trajectory, we start by knowing the horizontal velocity is constant, right? We start by knowing that. But I didn't shoot it at 20 meters per second horizontally. I shot it 20 meters per second at an angle. So I have to find out what part of that 20 meters per second is in the horizontal direction. So if you're eliminating answers and you still don't know how to do it, you at least know, well, it's not going 0. And you at least know, well, it's not going 20 meters per second. So you can eliminate A and B right away, right? But then you've got to think about what is the horizontal velocity going to be, and then you think, well, I'm going to have to use a trig function to figure that out real quick. And you recognize that's the adjacent side, right? And you've got the hypotenuse, and you know that to figure that out, then you're going to have to use a cosine, right? Because cosine adjacent hypotenuse. So you write out the definition of cosine equals A over H. And you can say that this is V in the X direction. So that's Vx over V. And you realize then I'm going to have to multiply this 20 meters per second times the cosine of theta, whatever theta happens to be. In this case, it's 60 degrees. So I created a drawing that's a little bit off. It should have been a little bit higher, shouldn't it? What trig fact that I should know about the cosine of 60 degrees would help me out here? What do I know that the cosine of 60 degrees is? It's the same as sine of 30 degrees. Crickets. Okay? You guys need to know this. The sine of 30 degrees is 1/2. Okay? Therefore, the cosine of 60 degrees is also 1/2. So whatever this is, 1/2 times 20 is going to be 10 meters per second. Okay? And if you draw this correctly, if you drew this at like 60 degrees, you would be able to see that even without doing the math, you'd be able to see that without even doing the math, this adjacent side right here really doesn't make up that much of the hypotenuse, does it? This adjacent side, remember, these are just ratios. The ratio of the adjacent side to the hypotenuse, okay? And this looks like it might be about 1/2 of the length of the hypotenuse, right? I can even sort of swing it up there, and it looks like it might be about 1/2 the length of the hypotenuse. You don't even really need to do any math here to figure out what that velocity was, at least according to these answers. Okay? There's a lot of little tips and tricks in there that if you remember those things, infinite help on standardized tests. Okay? Infinite help on standardized tests. How many people missed that? I only had 8 out of 27 get that question correct. Okay? Don't be those 19 people. Dang, I must have really sucked as a teacher that year. Who knows, maybe I still do. A pilot drops a bomb from a plane flying horizontally at a constant speed. Neglecting air resistance, when the bomb hits the ground, the horizontal location of the plane will beware. It's going to be over the bomb, right? We talked about this. Okay, so if I've got boy, that's a sucky airplane, isn't it? Okay, so if I drop my bomb, because both of these things are traveling at the same velocity, right? When that bomb drops, it's traveling in the x direction at the same velocity as the airplane is. And if we ignore air resistance, it will fly until it hits the ground at the same speed that the airplane does. So the airplane will be directly over the bomb when the bomb goes off. Okay, answer D. Okay, does that make sense? Package of supplies is dropped from a plane. 1 second later, a second package is dropped. Neglecting air resistance, the distance between the falling packages will. Okay? And there is a major trickiness to this question. You're going to say, well, Marshall, you told us that things fall at the same rate, so there's not going to be any increase in distance between the packages. Okay? But think about it. If I drop the package, the first package, and 1 second later, I drop the second package. When I drop the first package, or when I drop the second package, the first package is going to be here. 1 second later, I'm going to have gone farther than I did for the first second. And so when by 2 seconds that package is here, this package is where the first package was after 1 second, right? Another second passes. A2 or A is going to fall still farther, and by the second, B is going to be where A was at 2 seconds. So what's happening to the distance between the packages after each second? It's increasing. Okay? So you have two choices. You either know this because we talked about it and we said this is a tricky problem, or you do this when you get to the problem if you forget. Okay? Just write out a little diagram and see what is happening after each second. Okay? I expect more than half of you to get this correct. Okay? These are definite applications of these principles, right? Plane flying horizontally at a speed of 50 meters per second and at an elevation of 160 meters drops a package. 2 seconds later, it drops a second package. How far apart will the two packages land on the ground? And again, I know you can see the answers, but the packages, when they leave the plane, are going to be going 50 meters per second, right? The packages leave the plane, they're going to be going 50 meters per second. So I drop one, and it hits the ground. I drop another one 2 seconds after I drop the first one. It doesn't matter actually how high up I am. It just matters how fast the airplane is going. The airplane's going 50 meters per second, and after 2 seconds, it will be 100 meters further than it was. Therefore, the second package will hit the ground 100 meters after the first one. Right?
And then the second package will follow this.
Okay, so it doesn't matter how high up they are. Second package was released 2 seconds after the first. It was released 100 meters past where the first package was released. Therefore, it will also land 100 meters past where the first package hit. Bullet is fired horizontally, and at the same instant, a second bullet is dropped from the same height. Compare the times of the fall of the two bullets. Got one doing this, and I've got one doing this. Okay? Both of these are going to be under the influence of gravity, right? They're both going to fall in a vertical direction at the same rate. Okay? It's inconceivable to most people that the bullets are going to hit the ground at the same time. Okay? They'll try to say, well, you're firing this over such a long distance, it's going to be so long before it hits the ground. No, it's not going to be any longer before it hits the ground than this bullet. Mythbusters proved it. We need to watch that video. Okay, they hit the ground at the same time. Any questions about that? Stone is thrown horizontally from the top of a tower at the same instant a ball is dropped vertically. This is not the same question. Okay, this is not the same question. The last one asked, how long will it take for them to hit the ground? This question asks, which one's going to be traveling faster when it hits the ground? Okay, the thing about this is, I start out at 0 meters per second here in the vertical direction, and I'm going to hit the ground with whatever velocity the acceleration due to gravity imparts to me. However, I'm thrown at some velocity, let's say 10 meters per second. Okay, I'm thrown at a velocity of 10 meters per second, and I'm going to maintain that 10 meters per second, plus I'm going to add the velocity that gravity adds. Okay? So it should make sense then that this ball is going to be going, oh, so we've got a ball and a stone. So the stone is going to be going faster, right? The stone is going to be going faster since it was the horizontal one. Okay? So it's not enough that I give you kind of a tricky question. I have to make it more tricky by giving you two different objects. Okay? So right here, I'm only going to get the velocity of just falling straight down. Here, I'm going to have that 10 meters per second plus the acceleration due to gravities. So I'm going to have that little bit of extra velocity there, okay? My velocity is going to be the sum of those two velocity vectors. Here, I'm just going to be the sum of that velocity vector. Any questions about that one? Ball is thrown at an original speed of 8.4 meters per second at an angle of 32.9 above the horizontal. So I'm usually going to write out a little diagram to help me see what's going on. Okay, so this ball is thrown at this velocity at that angle. What is the speed of the ball when it returns to the same horizontal level? Okay, now notice I said what's the speed, not what's the velocity. When it returns to that same spot, when it hits the ground at that same horizontal level, what's its speed going to be? It's going to be the same, right? However fast I threw it there, that's how fast it's going to hit the ground. But the velocity would be negative 8.4, wouldn't it? Because the velocity, well, it would be 8.4 in the opposite direction as this is, okay? Because the velocity would be in the opposite direction. Okay? So 8.4 meters per second. We might actually get through all of this. When a football in a field goal attempt reaches its maximum height, how does its speed compare to its initial speed? Its maximum height is right here. And I kicked it at some velocity. We'll say that Kyson kicked it at some velocity. Let's say 20 meters per second. We don't really need to know for sure. But we kicked it at 20 meters per second. And some of that velocity is in the horizontal direction. Some of that velocity is in the vertical direction. Okay, now when I get to the center there, what velocity am I going to just have? Am I going to have any vertical velocity there? It's all horizontal velocity, right? That vertical velocity went away. Right? That vertical velocity did this. Right? Since that vertical velocity went away, there's no way it's still going 20 meters per second. Okay? The vertical part of this, whatever that vertical part was, went away, and now I'm just traveling in the x direction at that instant. So it's going to be less than its initial speed. Any questions? Okay. We're not going to do question 12.
Is that going to be on the test?
No. Otherwise, I would do it. Actually, let's talk about it, and I'll give you extra credit for it. How's that? Because I want to.
I wouldn't have crossed it out.
Well, just write EC for it. Okay? The acceleration of an object is always directed perpendicular to its velocity. If I'm an object, according to Newton's first law of motion, if I'm an object, I want to stay in the motion that I'm in. I resist a change in motion. I resist being accelerated. Okay? Think of a tracks train going 30 meters per second. It's going to be difficult to change its motion. Okay? It wants to keep going in a straight line at the same velocity. But if I have an acceleration on this, if I have a net force acting on it, at the same time it wants to go this way, hopefully it makes sense that it's going to change its motion, right? If I accelerate this towards the center of a circle, when it gets to this point right here, it wanted to be there, okay? When it gets to this point right here, it wanted to be there, but the force pulled it towards the center of the circle. When it gets to this point right here, it wanted to be up here, but something pulled it towards the center of the circle. So if I have a force that's acting on an object that's perpendicular, it will cause the motion to be circular. So the object is turning, okay? And we'll learn about circular motion in probably about a month and a half. If the acceleration of the vector is directed anti-parallel to the velocity vector, acceleration, if it was parallel, if this was acceleration and this was velocity, what would be happening to the velocity here? If this was acceleration and this is the velocity at this instant, what would happen to the velocity if I had an acceleration in this direction? It's going to be increasing, right? Okay? It's going to increase. But what if I had an acceleration in the anti-parallel direction? It's going to slow it down, isn't it? If I have a velocity vector or an acceleration vector in the anti-parallel direction, it's going to slow it down. Okay, so the object is slowing down. Now, why would the object is moving in the negative x direction not be correct? In this case, it is not moving in the negative x direction. It might be eventually, if that acceleration keeps going, it's going to turn around and keep going, right? But it could be that I'm just slowing it down in the positive x direction. So anti-parallel is just 180 degrees away from where you're headed. Okay, so if my acceleration is anti-parallel to my velocity, I'm going to slow down, even if I'm going in the negative direction. If I'm going in the negative direction and I have an acceleration in the positive direction, it's going to slow it down in the negative direction. Okay. How do we think we can do on the multiple choice questions? Think we can nail those? Okay, again, I will change the order of the answers. It will be that you have to actually know these. I might do something like change this and say if the acceleration vector is directed parallel to the velocity vector, I can change that, right? Okay, so I could change that. I could say, like on this one, a football and a field goal attempt reaches its maximum height. Instead of saying how does its speed compare to its initial speed, I might just ask you what is the vertical velocity at that point, okay? So I can change these questions up in subtle ways so that you're not just regurgitating answers that I've given you. Okay, so make sure you understand these things rather than just memorizing them. Actually read through. These are really good descriptions of what's going on. I pride myself on being able to describe things like that pretty well. So, okay. Quantitative problems. In projectile motion, you know that to analyze the motion, you have to break the motion into x and y components and to analyze each of these separately. You know that motion in the x direction is constant. So to analyze motion in the x direction, you can only use the formula that's used for constant velocity. If I want to find out something about the x direction, I have to use this formula. Okay? You know that we're not even going to approach the range formula. That's not a high school level. That's an AP question. You know that motion in the y direction is accelerated according to the acceleration due to gravity. Therefore, to analyze motion in the y direction, you can either use the velocity formula, a final velocity equals initial velocity plus acceleration times time, or you can use the displacement formula. Okay. Stone is thrown horizontally with an initial speed of 8.5 meters per second from the edge of a cliff. A stopwatch measures the stone's trajectory from the top of the cliff to the bottom to be 3.6 seconds. What is the height of the cliff? Okay, so I'm going to cover that up a little bit. I know you can see it on your paper, but let's just pay attention up here. Stone is thrown horizontally with an initial speed of 8.5 meters per second from the edge of a cliff. A stopwatch measures the stone's trajectory time from the top of the cliff to the bottom to be 3.6 seconds. Okay? So, if you want, you can create a motion diagram, and you can say x0 equals 0 meters, vx equals 8.5 meters per second. You don't know what y0 is. That's what you're trying to find, right? Trying to find y0. And you know that it's going to be accelerated at negative 9.8 meters per second squared. You know that y is going to be, your final y position is going to be 0. Okay? And you also know that your initial y velocity is going to equal 0 meters per second, right? If I'm in a horizontal launch, I'm not moving up or down at all. So if you wanted to create a a motion diagram like this, you could. You also know that we're speeding up. I don't know what my final y velocity is. That's a question mark. But I'm not asked to find that. I want to know what the height of the cliff is. So as I'm thinking about this, is y, the height of the cliff, an x thing or a y thing? It's a y thing, isn't it? I only have two y. I only have two y formulas. I have Vy equals Vy0 plus acceleration times time. That's only going to give me velocity, and I have y equals y0 plus Vy0 times time plus 1/2 at squared. Okay? And of course, you'll have these formulas. And instead of doing this, I can just think to myself, that's a y thing. I know I need to use this formula. So at the very least, I'll need you to write out this formula for me. Okay? You'll need to write out the formula. Then I would cross out things that are going to drop out. This y is going to be 0. Vy0, my initial y velocity is going to be 0. My final y position is going to be 0. So this whole thing is going to drop out. Don't keep the time in there. And I know that to find time, or no, I want to know my height, right? So I want to know y0. So y0 is going to equal negative 1/2 at squared, right? Because in order to get y0 by itself, I'm going to have to subtract this to the other side of the equation. Equals negative 1/2 times negative 9.8 meters per second squared times 3.6 seconds squared. Now, for some reason, even though I said 3.6 up there in my answer key, I put 5.6. I'm wondering if I still calculated it correctly, because that shouldn't be 5.6. Someone want to calculate this for me? 1/2 times 9.8 times 3.6 squared. It should only be about 50, I think.
I got 63.5.
Okay, so that's the wrong answer, 63.5 meters, okay? Because it should be 3.6 meters per second squared, not 5.6. Okay, so at the bare minimum, I need to see this, okay? 3 points for something like this. 1 point for writing out the equation, 1 point for substituting the values in for it, and 1 point for the calculation. So if you just wrote down 63.5, you would get 1 out of 3 points. I need to see the equation. I need to see substitution of values into the equation, and I need to see the final answer. That is the way I want your answers to appear. Any questions about that one? Okay. Similar type of problem. A rock is thrown horizontally. velocity of 16 meters per second from a bridge, falls 33 meters to the water below. How far does it travel horizontally before striking the water? Okay, you're reading through this. You can write out a motion diagram if you want, but you can also reason, how far does the rock travel horizontally? Okay, is that an X thing or a Y thing? X thing, right? X is horizontal. I only have one formula that can help me here. X equals X0 plus VT, right? So I'm thinking, well, I just need to write that down and I should be able to solve the problem. X equals X0 plus Vx times time. And I know that X0 drops out. And I want to find X. So all I have to do is plug in velocity, which is 16 meters per second. And then, wait a minute, I don't have time. Okay? This will almost always be the case in a horizontal launch problem when you're trying to find out how far something went. I will almost always make you find time as well. Okay? And we said that in a horizontal launch problem, the only way I can find time is to use y equals y0 plus vy0 times time plus 1/2 at squared. Okay? And again, you'll get these formulas, but I will need you to know how to use these formulas, right? I'm not going to sit there and say, okay, for this one you have to use that. I might give you a little bit of a clue. I might say something like, this formula might be useful to help you find time in a horizontal launch problem. Okay, so I might give you a little clue like that. But then I got to come over here and write this out. Y equals y0 plus vy0 times time plus 1/2 at squared. And I know that this term drops out because I don't have a y velocity. It's 0. 0 times time is 0. And I know that my final y position is 0. And I want time. So to get time by itself, I'm going to subtract y0 from both sides of the equation. Then I'm going to multiply both sides of the equation times 2 so that I can get rid of that denominator. Okay? Then I'm going to divide by a, and that will give me t squared, but I want t, so I know that t equals the square root of -2 times y0 over a. So -2 times y0, how far up did I say it was? 33 meters? 33 meters over -9.8 meters per second squared. And that should give me time. Then I can take that time and plug it back into the original equation. So here in my notes, I said in the vast majority of problems, if you need to determine an x direction, you will almost always need to find time. The only way that you'll be able to do this is by using y direction calculations. Make this an intuitive part of your problem-solving skills for projectile motion. For horizontal launch, you can memorize this if you want to. I'm not going to give it to you on the test, but some of you might know this. Okay, and this is what we did. So that equaled 2.60 seconds, and then I just plugged that back into my original equation, and that equals 41.6 meters. So it landed 41.6 meters. Any question about those two problems? Okay, we're all still acing this, right? A ball thrown horizontally from a point 79 meters above the ground strikes the ground after traveling horizontally for a distance of 46 meters. Okay? By now we should be used to this. In order to find out what its velocity is, I'm going to have to use this question or this formula right here, and I'll solve it for velocity and realize, hey, I don't have time. I have the 46 meters, but I don't have time. So I'm going to have to find time again. And if you figured out that time in the previous problem was the square root of negative 2y0 over a, you can just use that formula. You don't have to go through all of this. You could just write this down and plug your values in and get time. Okay, so these first three problems are, what are the ways that I can test you on horizontal launch? What are the ways that I can test you on horizontal launch? Okay. Now what about angled launch? And we just did this problem last time. And let me just check out something here. Okay. So a jumper in the long jump, I'll probably change the scenario here, but it'll be the same type of a problem. A jumper in the long jump goes in the jump with a speed of 13.5 meters per second and an angle of 23.3 above the horizontal. Okay, and what I've told you is that anytime you have a problem with an angled launch, the first thing you probably want to do is find out what the velocity in the x direction is and the velocity in the y direction is. Remember that the velocity you're given is the velocity at an angled direction. And in this case, we're saying it's 13.5 meters per second. Okay, so dude takes off 13.5 meters per second this way, but I'm probably not going to want to know a whole lot about his flight. I'm going to want to know how far he's going to go. Okay, so I've got an angle here, and I want to know how far he's going to go, so I'm eventually going to need the Vx, right? And when I get this far, I should just label my triangle. This is the adjacent side, this is the opposite side, this is the hypotenuse. And if you don't know by now that Vx, my velocity in the x direction, is going to be V cosine of theta, and my velocity in the y direction is going to be V sine of theta, that's okay. Okay? One thing you can do is just simply recognize this is going to be the adjacent side, so I know it's got to be cosine of theta, and oh yeah, I have to multiply by my main vector here to get Vx. The other thing you can do is say, oh, V sine of, this is the opposite side, so I'm going to have to multiply V times the sine of theta. Or if you completely forget, since you know that the adjacent and the hypotenuse involve the cosine, you can write out cosine of theta equals A over H. And oh, by the way, that's Vx over V. And I want Vx, right? That's what I want. So I can just see that Vx is going to equal V times the cosine of theta. Likewise, I could say sine of theta equals opposite over hypotenuse equals Vy over V. I want Vy. So I'm just going to multiply V times the sine of theta. What is it? Is that probably the 10th or the 11th time I've shown you how to do that, right? Probably. Okay. You have at least 2 or 3 different ways that you can figure out what these formulas are going to be. Never mind the fact that I will give you those formulas on the test. Okay? But if it doesn't occur to you that I've given you those formulas on the test, you have other ways to figure that out. Okay? So that's the first thing that you're going to do. Okay? Regardless of what the question is asking, and this is about the only time I'll ask you to do something different first than write down something that will answer your question, right? Normally I'll say, write down a formula that will answer your question, and then go. But here I'm saying, do this stuff first, because you'll need those values. So here's what I said. In this case, you're told that this is an angled launch, and you know you're likely to have to calculate Vx and Vy0, so I would normally go ahead and do this first. Even if you just do that, I'll give you some credit, even though you haven't really addressed the problem. So in the first one, you're asked to find time. Okay? And we said that in angled launch, I can't use y equals y0 plus vy0 times time plus 1/2 at squared. I can't use that because Vy0 times time doesn't drop out, okay? And that would mean I would have to solve a quadratic formula to find t, because I would have t and t squared in the same formula, and I don't want to do that. I could, but I don't want to, so we're not going to be able to do that, okay? So you quickly realize you would not be able to use an x direction calculation because you have no x displacement, right? You haven't been told how far you're going. So you're still going to have to use a y calculation. And in this case, we're going to have to use this formula, okay? And I showed you last time how to isolate time using this formula. And I told you to remember that if I land at the same height as I start from, these two values have to be equal to each other. The velocity in the y direction at the beginning here is also going to be the same thing as Vy. When I go up, I'm going to have a certain y velocity. When I come down, I'm going to have that same y velocity. It's just going to be in the opposite direction. So what I said is, I can substitute Vy0 in for, or negative Vy0 in for this, because the negative of this is this, right? Vy here, or Vy0 here, negative Vy0 there. So I'm just going to substitute negative Vy0 in for the formula. So I'm going to have negative Vy0 equals Vy0 plus At, right? And then I'm going to subtract that one, and I'm going to have negative 2 Vy0, okay? And then I'm going to divide by A, and that's going to give me t equals negative 2 Vy0 over A. Okay, so isolating T gives you that. Okay? And again, that will be something you'll have to be able to do. Okay, you'll have to be able to find time using this formula instead of the other formula. Okay, and so I wanted to find time, and I know that Vy0, because I've already calculated it, equals 5.34 meters per second. And I plug that in, and I get 1.09 seconds. Okay. Then I want to know how far the jumper jumps. That's an x thing, right? X equals x0 plus vx times time. And I've already found that Vx equals 12.4 meters per second because I did that the first thing, right? I came up here and did that to start with. And now all I have to do is just plug that value in for Vx. And then since I already know what the time is from the first problem, I get that. Any questions about that problem? Okay. Projectile is launched with an initial velocity of 45.8 meters per second and an angle of 43 degrees, 43.3 degrees, 43.4 degrees. V equals 45.8 meters per second. What is the maximum height? I know this is a y thing, right? What's the maximum height? How high up does it go? And I know that I need to use y equals y0 plus vy0 times time plus 1/2 at squared. Okay? I would still go ahead and find Vx and Vy. Okay? You're only going to need Vy in this case, but I still would appreciate it if you went ahead and found Vx. And Vx is going to be equal to V cosine of theta, and Vy is going to be equal to the V sine of theta. Okay? So I know that my initial height is going to be 0. I know that my final height is also going to be 0, right? I'm going to start out at 0 here. I'm going to end up at 0. Okay? But after I figure out what my initial velocity is, my initial y velocity is, I don't know how much time I have. Okay? So I'm going to have to use Vy equals Vy0 plus acceleration times time and find time. This is different than finding the time of the whole flight. This is different, okay? I'm going to pretend that this is my final y velocity here. Right here is where I want to know how high I am, so that's where my final y velocity is going to be. And at that point, my final y velocity is going to be 0, right? My final y velocity is going to be 0. Okay, so in order to find time, I'm going to have to subtract Vy0 from both sides and then divide by A, and that's going to give me time. Okay, so to find half that, I'm going to need to divide my original y velocity divided by A, and then I can go back and plug in time. So I've done that here. T equals negative Vy0 over A. I found out how much time it took for half of the flight, and then I went in, plugged those numbers back into my Y formula, and I got that height. Okay, now 19 and 20 we didn't talk about. We're not going to do those, so scratch out 19.
That's only.
Oh, did I?
You didn't push them off.
Ended at 18.
I ended at 18. Okay. I've got one more problem I want to be on this test that talks about components. And it'll be a fairly short, easy problem. It'll be the one where you're taking the flight to Disneyland and you take off at a certain velocity, and I want to know what your ground speed is, and I want to know what your ascent speed is. But then, yeah.
When are we taking this test?
A week from tomorrow. Okay, the day before break. Okay.
Good.
So we'll have a lab on Wednesday. We'll talk a little bit more about this test on Friday, and we'll take the test on Tuesday. Okay, assuming that we're here.
Will we just fix the test online?
Yeah. Is this an adequate study guide?
Very much.
Okay? You know exactly what's going to be on the test. I don't believe in telling you to study things that aren't going to be on the test, or might be on the test, or might not be on the test. So, if you know what's on this, you'll do really well.